Good evening, my YouTube viewers. It is Crystal here. I'm just here this evening because what I wanted to do is I wanted to do a code review. I wanted to do a code review on the statistical formula called coefficient of variation. So what I've done is I've called up Wikipedia just to give you a definition of the coefficient of variation. And just quite in very simple terms, in probability theory and statistics, the coefficient of variation, CV, also known as relative standard deviation, RST, is a standardized measure of dispersion of a probability distribution or frequency distribution. It is often expressed as a percentage and is defined as the ratio of the standard deviation to the mean or its absolute value. The CV or RST is widely used in analytical chemistry to express the precision and repeatability of an assay. It is also commonly used in fields such as engineering or physics when doing quality assurance studies and ANOVA gauge R&R. In addition, CV is utilized by economists and investors in economic models. So that's your coefficient of variation, and I got this from a course I'm taking on statistics. So it gives you a definition of coefficient of variation. It's defined as the ratio of the standard deviation to the mean, and so they give you that. So now what we'll do is we're going to leave Wikipedia and we're going to go over to Google Colab, which is my platform of choice, and we're going to give you the formula for how to calculate coefficient of variation. The CV equals standard deviation over mean times 100. So what you need to do is you have to know how to calculate standard deviation, and then you have to know how to calculate mean in order to get the coefficient of variation. So what we'll do, the first thing we'll do is we'll come over here to my Jupyter notebook that has statistics functions in it. And this is your standard deviation. And in order to know the standard deviation is the square root of the variance. So you have to know how to calculate variance in order to calculate standard deviation. So fortunately, we don't have to worry about median in this video. But here's your variance. Here's the function on how to calculate variance. And you also need to calculate mean. So in order to calculate the coefficient of variation, you have to know how to calculate the mean. You have to know how to calculate the standard deviation. And you have to know how to calculate variance. So you have to know 3 formulas before you can get the coefficient of variance. Now, what I've done previously is I did a code review on these statistical formulas, but what I'm going to have to do is I'm going to have to go through and do a code review on the 3 statistical formulas again, just to get you to the point where you can calculate your coefficient of variance. So the first thing that you need to know how to calculate is your standard deviation, which is right here. But in order to calculate the standard deviation, you need to know how to calculate variance. So we'll come over here to variance. So this is the formula for variance. So what we're going to do is we're going to use Python to calculate the variance. So def calc variance is we're going to define the function, and it's going to take a list of numbers as its input. Mean x equals calc mean. So you have to know mean. So you have to know how to calculate the mean in order to get the variance. So the mean is the sum of terms over the number of terms. So you def calc mean x, temp equals 0 for I in range 0 to len x, temp equals temp plus xi, temp, and then when that's iterated through, you go temp equals temp over len x, and you return temp, and that is how you calculate your mean. So we go back to variance, where it said you had to calculate the mean. So mean equals calc mean x. It takes a list of numbers as an input. Your numerator equals 0. Diff from mean is an empty array. For I in range 0, len x, step of 1. The diff from mean append xi minus mean I, because you've already got your mean. Numerator equals numerator plus diff from mean I squared. And variance x equals numerator over len x. And then the function will actually return the variance of x. So after we got our variance, we're going to calculate the formula for standard deviation, which is simply the square root of variance. So def, we're going to define our function, which is def calc std. It's going to take a array of numbers as input. Variance x equals calc variance x. So we've already gone through the variance function. Stdx equals variance x, this is square root, times the power of 0.5, which is the square root of variance x. And it's going to return stdx. And so you can see the standard deviation is the square root of your variance. So now what we've done is we've gone through 3 formulas that you need to know in order to calculate the coefficient of variation. These 3 formulas are the mean, the variance, and the STD. So now what we're going to do is, since we've got these 3 functions established and defined, we're going to use these 3 functions in the one function that we're going to make to calculate the coefficient of the variation. So it's going to be def calc CP. So we're going to define the function to calculate CV, and it's going to take a string of an array of numbers as an input. And so stdx equals calc stdx. Mean x equals calc mean x. Coef var equals stdx over mean x times 100. And then the function is going to return the coef var. And so the coefficient of variation in this instance is 37.39. So what we can do is, now that we've done all that, we're doing our code review. Let's just 10, 20, 15, 5, 25, 7, 6, 2, 3. So let's see what we come up with. Oh, I messed that up, didn't I? So it's going to go into an error because I didn't start it from the beginning. So it gives you your difference for your mean, and it still gives you a coefficient of variation is 72. And what I was reading was that if it has a coefficient of variation of 5%, then it's pretty good. And if it has a coefficient of variation of more than 10%, then you need to worry. So just to do this, so it still gives you a coefficient of variation of 47. So we'll just try this out. So I'll give you a coefficient of variation of 43. So I've got the formula correct, but obviously because I'm still studying statistics, you know, I'm just putting numbers in, numbers that I've made up in. So it gives you a coefficient of variation of 43. But from what I read today about it, you need to have a coefficient of variation of less than 10 before it's going to be cause for concern. So we'll just have to keep studying statistics, but you do have the formula to calculate coefficient of variation, and you've got it written in Python, and so you're able to calculate the coefficient of variation as well as the mean, the standard deviation, and the variance to find all of this information. And hopefully you'll be able to use this in your statistics work, and you'll be able to use it in your programs. So I'm going to go ahead and conclude this video because I've talked about mean, variance, standard deviation, and coefficient of variance. And that's all you need to know for this video. I would like to thank all of my subscribers for supporting me in this channel. And if you like this video, please like, subscribe, and share. And I look forward to making more videos for you in the future.